Here's today's master check key. The first question says factor the trinomial. The trinomial, I know that maybe I didn't say this vocabulary word, but 1, 2, 3, 3 terms. That's what a trinomial is. What I need to do is I need to find two numbers that multiply to a times c and add to b. So a times c is negative 18, b is 7. So the factors of negative 18, that would give me, I could do 1 and negative 18, 2 and negative 9, 3 and negative 6, I could do 6 and negative 3, I could do negative 9 and 2, I could do 9 and negative 2, and I could do 18 and negative 1. This is the pair I'm going to use, so in the box method I'm going to use k squared here, I'm going to put negative 18 here, I'm going to put 9k here, and I'm going to put negative 2k here. So I chose that because these two numbers add to b and they multiply to negative 18. Put one of them here, put one of them here, make sure that the k's represent this right here. This spot has to be matched by these two boxes. Okay. What's common between these two is a negative and a 2, because they're both even numbers and there's a negative in both of them. If this is negative 2, then this times this has to give you negative 18, which makes this positive 9, because 9 times negative 2 is 18, negative 18. This is 9. I'm missing a k here, so I have to put a k here. This is a k. I have a k squared. I'm missing another k. And then just to check to make sure your work works, take your k and multiply by negative 2, and it should work right here. And it does. So we get k plus 9 and k minus 2. Our answer is right here. If you got k minus 2 times k plus 9, that's the same as this, because it doesn't matter what order you write the multiplication in. Same type of question here, so I'm going to do the same process. A times c is 48. B is negative, sorry, this has got to be a negative 48. B is negative 47. So I'm going to be working with negative 48 and 1 is my pair. So I'm going to put my 6v here, so v squared here. I'm going to put my negative 8 here, so I have these two, and then I've got to have my negative 48 here, and I've got to have my 1v. I'm just going to write v. Okay. What's common between these two terms? It's got to be a negative 8, because negative 8 goes into both of these terms. What am I missing over here? I'm not missing anything, so I've just got to put 1. 1 times this spot has to give me v, so this has got to be v. This times this has to give me this, so what am I missing? I'm missing a 6v. Let's just check our work. 6v times negative 8 is negative 48v, and so this all works. My factoring is going to be 6v plus 1 and v minus 8. Where do I see both of these things? It's this one. This one is written in an opposite order from this one, but that doesn't matter because the multiplication works both ways. Okay, next question. Solve the equation by factoring and using the zero product property. Solutions are listed as 2x values. So let's start by factoring like we've been doing. I don't even know what 7 times 12 is, so just do it in your calculator. 7 times 12 is 84. So we're looking for factors of 84 that add to 25. Okay, so a times c is 84, b is 25. So let's think about this. 84 and 1. I could have 42 and 2. Could have 28 and 3. I have 21 and 4. There's my winning pair. Once you get to it, you don't really need to go any further. So I have my positive 4 and my positive 21. Those two add to 25 and they multiply to 84. So my factoring looks like this. 7p squared, 12, 25p, nope, just kidding, 21p, and 4p. What's common between the 4p and the 12? It's got to be just the 4. If this is 4, this is 12, this has to be 3 because 3 times 4 is 12. 3 times what gives you 21p? It's got to be 7p, and then 7p times p is 7p squared. This works also. Okay, so my factoring is p plus 3 times 7p plus 4 equals 0. The reason I can say that it's equals 0 is because this is equals 0. So then this whole thing is equal to this whole thing. This is 0, this is 0. So now I've done the factoring part. Now I got to use the zero product property to solve. So I can say p plus 3 is 0, and I can do 7p plus 4 equals 0. Solve for p. P equals negative 3. There's one solution. Minus 4, minus 4. I get 7p equals negative 4. Divide by 7, divide by 7. I get p is negative 4/7. Where is the pair that matches that? I have negative 3 and 4/7, so it's got to be D. Last one, same question. Okay. Solve the equation by factoring using the zero product property, same strategy as we just did. AC is 9, B is 10. The only thing I can think of would be 9 and 1, because 9 times 1 is 9, 9 plus 1 is 10. So, in the box method, I'm going to say 3a squared, 3, 9a, and 1a. What's common between the 3 and the 9a? It's got to be a 3. That makes this a 1. That makes this an a. That makes this a 3a. So my answers are 3a plus 1 and a plus 3 equals 0. Okay. This whole thing is equal to this whole thing because we factored it. I have it equal to 0 because it was originally equal to 0. Now I can use the zero product property. I can say 3a plus 1 equals 0, and I can say a plus 3 equals 0. Okay. Subtract 3, a equals negative 3. There's one solution. Minus 1, minus 1. 3a equals negative 1. Divide by 3, divide by 3. I get a equals negative 1/3. There's the other answer. Where does it match? Right here. So my answer is A.